Good evening, everyone. Welcome to Tau Iota Chapter's presentation of a vaccine discussion for COVID-19. I'd like to thank you all for attending this evening and taking time out of your busy holiday schedule. For over 109 years, the Omega Psi Phi Fraternity Incorporated has been a beacon of hope and understanding in our communities worldwide. Locally, in Hartford, Connecticut, the Tau Iota Chapter will be celebrating 75 years of serving the community next year. While we plan for this historic event, we are ever reminded of the world that we live in right now. Throughout the world, people are dying from this deadly virus. What we'd like to do here tonight is not try to convince anyone to take a vaccine. What we'd like to do is present individuals who have the knowledge, the understanding to inform you properly on what the vaccine is and what it is not. All of these men, I'm glad to say, are my fraternity brothers and close friends. So with that, we have a little bit of housekeeping to get to before we begin. The Q&A section of the Zoom will be available for questions as well as the chat section. What we'd like to do right now is display a polling question to get a little bit of an understanding from your perspective, what you think about taking the vaccine right now. We have to remind you at the end of the discussion, we will present this polling question again to see what your views are, having learned a little bit more tonight. So please stay tuned, sit tight, and you're going to hear a great presentation with a tremendous amount of information. I'd like to introduce my fraternity brother, Greg Jones, who is the VP of Community Health and Outreach for Hartford Healthcare, as well he's on the communication subgroup of the Connecticut Vaccine Advisory Council. Brother Jones, take it away.
Thank you, Joseph. I appreciate it. And to all that are joining us on the holiday season, thank you for sharing a little bit of your time with us this evening. I'm pleased that you are joining us on a very important topic that Joseph mentioned earlier. And as he indicated, the Omega Psi Phi fraternity has been in the forefront of health issues, especially as it relates to Black men. I hearken back on our initiative almost 7 years ago when we started the Black Men's Health Project here in Hartford, Connecticut, where we did an outreach by going through neighborhoods and reaching out to barbershops and churches to really engage Black men about health. This particular seminar and series is an extension of our dedication and interest in the health of our community. So we're pleased to have you. I am pleased also to be the pregame, the preliminary, just a few minutes before you hear the substance for Dr. Eadie, who will give you substantive information about the vaccine and its current testing and current issues with folks getting the vaccine, and all the information you need about the vaccine. So I'm excited to hear it again. I listen to him often and can't do it often enough, I should say, hear the good information coming from Dr. Eadie. But with that, I'm going to share with you just a few slides, as I said, just a prelim of what to level set our discussion this evening, a few social science observations. So I'm going to play a social scientist just for a few slides, and then at the end, hopefully play an epidemiologist. I like playing things in the world in which I'm participating in. Next slide, Abby. So we started this series of seminars because we realized that there was a gap in terms of folks interested in taking or accepting the vaccine, which is what the poll that you took earlier, along with information that they would receive from politicians, doctors, and federal officials. There was a gap. So at the beginning, if the COVID vaccine, and this was done probably in November, mid-November, pre-vaccine release, and we polled the area of North Hartford. And those in the Hartford area will know that would be the zip codes of 06112 and 06120. For those outside of the Hartford, Connecticut area, it is the most urban area, primarily dominated by folks of African-American descent. We really wanted to find out what the sensitivity and what the interest was among that particular population. So as you see, 50% of the participants responded that they were very unlikely, which is right on top of where the national surveys are as it relates to vaccines pre-release. Since that time, we've seen a relative uptick in interest. Recent Pew research and Kaiser Family Foundation research says that in the Black community, about 60% now are saying that they would be interested in receiving the vaccine. We believe, or would like to believe, a large part of that uptick is a result of solid information, some of which you will hear tonight from Dr. Eadie. So when we asked the participants, who did they trust? 86% of them trust their doctors, 35% trusted state and local officials, 20% trusted federal officials. So the gap was 50% of the people said I would take the vaccine, but 86% of them said I trust my doctor. Our goal at the Omega Psi Phi fraternity and with this health initiative is how can we close that gap? We can close that gap if we got people of sound backgrounds, trusted individuals, medical professionals, had an opportunity to speak to the audience that we were talking to get them comfortable about what all the aspects of the vaccine were. And that's what this program is about, reaching out and educating. We realize this gap. So our goal is to try to close that particular gap of folks from taking the vaccine, or at least understanding aspects of the vaccine, and those that trust their primary care physicians. Next one. This was a slide from our prior seminar. It shows that information does matter. At the beginning of the poll that you took, this is not your particular results. We will show your results at the end, but at the earlier seminar that we had on the 17th, 35% of the people said that they weren't interested in taking the survey. Following Dr. Eadie's presentation, information, and the question and answer session that they received from this seminar, that percentage went up to close to 60%. So it shows that information does matter. If you get solid information from trusted officials, you are able to make an informed decision. One of the things that I remember from our Black Men's Health Project that we talked about, our theme was be informed and be responsible. And that's all we're asking here, is to be informed and to be responsible. Next. So let's unpack a little bit of this hesitancy around the COVID vaccine. 86% trusted physicians, 50% unlikely. So how do we close the gap? So when we unpack this receptivity and hesitancy, we understand why. The proverbial elephant in the room, right? The medical community's relationship with Black and brown people. It's no secret that the mistrust in the medical community has been earned. It's been an earned mistrust. Experimentation without consent. We know about Henrietta Lacks, the Holmesburg prison experiment, J. Marlon Sims, who was thought to be a profound gynecologist that experimented on Black women, the Tuskegee syphilis study, birth control pills used on individuals in Puerto Rico. And it's not just historical. I'm sure we all have our own sensitivities around our own issues and instances with the medical community. So we understand that. We understand that mistrust. So therefore, what can we do to help that? We certainly understand there's been history, but can we give facts and data today that might get you a little bit more comfortable with the issues that we face as it relates to the most pressing issue of our time today medically, COVID vaccine and COVID-19. So a few things changed since the Tuskegee experiment. As I mentioned earlier, it was really around consent. And so the National Research Act, the National Commission on Protection of Human Subjects, now says that you got to have informed consent. And any studies involving human subject has to go through an institutional review board. That's just a part of the changes that occurred from Tuskegee. But I'm not trying to at all discern or discount folks' concern about what history has brought us to. It's just a mere sharing of the facts of where we were then and where we are now and what has been done. And I think Dr. Eadie will speak a little bit to that as well. So these were some of the comments that we tried to address to try to shape this particular seminar and other seminars that we will do around the COVID vaccine. It's not been enough clinical trials. It's been rushed to development. It's not been enough folks of Black and brown descent. All of these questions are questions that Dr. Eadie will answer. We understand what the market is saying. We understand what the public is asking. And so what we're trying to do is share information with you that you may become an advocate of sharing solid information around the COVID vaccine, COVID-19 vaccine. So a couple things here. 95% effectiveness. What we like to say, what I like to say, it's powerful. But just recently, as you know, over the holiday season, the virus has been spreading more rapidly than it has in prior times. We've had 200,000 cases mid-November, mid-December, 200,000 infections per day. In September, it was only 35,000 infections per day. So the spread of COVID-19 is outpacing somewhat of the effectiveness of the vaccine. In other words, we've got to help the vaccine. We've got to help. If we continue to spread, if the virus continues to spread at the levels of which it's spread, it's going to take us a lot longer to get out of this pandemic. So what can we do just as lay people, right? In addition to sharing information that we're sharing here, what else can we do? Because this fire hose of the vaccine, that's what I like to think about. If you get a visual of a forest fire and we got this very effective fire hose, the fire hose alone cannot stop the pandemic. It needs help. That help comes from us. So what can we do? Mask up all the time, always. Dr. Eadie will speak to that. Avoid unnecessary travel and gatherings. Minimize and eliminate. Ask yourself, is it necessary? Do I need to go? Because we do know that when we stay within our bubble, we have a better chance of maintaining and containing it, right? Social distance, avoid groups. And act and assume as everyone has it. Act and assume as you have it. So with those little things that we can do, we might be able to give the vaccine some help. And I encourage you to think about those things as you travel over the holidays or you stay with your family on the holidays. Think about masking up inside, outside. Think about whether that trip is absolutely necessary and help us help you and help the vaccine help us. One of the things I would like to do is that we've got a couple videos that we like to share. One of which is from our fraternity brother, Kevin Thompson, who is a nurse, who's on the front lines of fighting the COVID-19 and fighting the coronavirus. Kevin is a nurse at UConn Hospital. He's going to share a little bit of his story about healthcare and what he faces to try to bring this home about what people are really experiencing.
Hi, my name is Kevin Thompson. I'm a registered nurse here in Connecticut. Before the pandemic, I was working on a post-operative orthopedic floor. Since the pandemic, I've been working on a surge floor, which is a floor that pretty much was developed to be an overflow floor for COVID patients. Currently, I live at home with my wife and 2 children. As you can see, I live in a lovely basement, 5-star living situation here. But the truth is that due to my concerns as a father and a husband, I chose to live down here to pretty much avoid my family because I know that I'm a high-risk employee. To be honest with you, I have some of the same fears that everyone else has with the vaccine. I'm concerned. It's a new technology. It's a new vaccine. But I can't afford not to take the vaccine. I can't afford not to try something to help my family. I can't afford not to be next to my wife. I can't afford not to lay next to my kids. I can't afford it. So the truth is that I have to try the vaccine in order to get back to some level of normalcy around my family and my loved ones. And I can't be the danger that walks through the door every day.
Thank you. So that was Kevin Thompson, one of our fraternity brothers that really shares his concern as a healthcare professional about COVID and the concerns he has with his family. Next, we'd like to share a video with Dr. Corey Harwell, who was a participant in one of the vaccine studies. I'll let Corey tell his story, let Dr. Corey tell his story about his interest and participation in the vaccine study.
I'm currently an assistant professor in the Department of Neurobiology at Harvard Medical School. You know, my view as a scientist And as a Black person in America, I understand the reluctance about the process. But I think that with that, there's also opportunities to learn more about these processes and actually have a lot of faith in the integrity of the process and the integrity of the people who are carrying out this work. And you know, why all of these companies and all the scientists that work at these companies and all of the work from the scientists that work at the National Institutes of Health are, you know, stepping up to this opportunity to have a positive impact. I would definitely take it. I hope that my family does. And again, just going back to the personal motivation is that, you know, we know the risk for this virus, and you know, the risk is death. And depending on your comorbidities and your age, that risk is even higher. So again, you know, thinking about my parents and, you know, the health issues that they have, if there is a safe alternative for them to avoid infection and potentially death from this virus, then I want them to, you know, feel safe and feel secure about being able to take that.
Thank you, Dr. Corey. We appreciate it. We'll have these videos available on the Tau Iota Q's website that's listed here after these particular presentations this evening. So I will turn it over. I would encourage you to stay strong, mask up. I'll play my social scientist mask up wherever possible you can, avoid crowds, and I'll turn it back over to our bossless Joe Santana.
Thank you, Brother Jones. And I want to give a special thanks to Brother Kevin Thompson and Brother Corey Harwell for telling their stories about the pandemic and about the vaccine and what it means to them. As Brother Jones mentioned, I am the bossless of Tau Iota Chapter, so I'm in a unique position to lead part of our local efforts in terms of dealing with our community and our reactions to this pandemic. And for those of you who don't know, the bossless is another term for president of the chapter. Without further ado, I would like to introduce our brother, Dr. Reginald Harwell. He is the president and CEO of Trinity Health of New England, as well as the co-chair of the COVID-19 Advisory Council for the state of Connecticut. Brother, take it away.
Thank you, Brother President. It's a pleasure to be here. Great job to Brother Jones, who always does a phenomenal job. He does an amazing job in representing the community. And so, Brother Jones, thank you very much. I'm Dr. Reggie Eadie, President and CEO of Trinity Health of New England, and I'm going to talk very fast. We've got limited time. As our bossless said, it is the holiday season, so we thank you all for participating and don't want to take much time from you and your family. So jumping right in, if I can advance the slides here, let me see. There we go. All right, so, you know, our fraternity is based on our religion as Christians and Muslims and people from the Jewish faith. But I think we all agree on Hosea 4:6, which says, my people are destroyed because of the lack of knowledge, because you have rejected the knowledge. And so we think that today's conversation is relevant. Before we start, and our bossless has no idea I'm going to do this, so hopefully it goes over well. I thought we'd go through just a quick exercise to make sure that we're all on the same page. So with that, if you guys can just put in your thinking caps for just a second as an icebreaker. I'd like for you to pick a number, any number. You can drop the number in the text just to assume, in the chat box just to assume that you are, it's working properly. And Brother Bossless, feel free to throw out some numbers if you feel free, but if not, that's okay for the sake of time. But pick a number, any number. It can be a negative number, a positive number, a number that expands as far as your mind can take you. The intent here is to get us all on the same page. Once you've picked that number, please multiply that number by 3. So pick a number, any number, multiply it by 3. After you've done that, please add 6 to that number. So pick a number, any number, multiply it by 3, and then add 6. And then once you've added 6, please divide that number by 3. You're going to multiply it by 3. You're going to add 6. You're going to divide it by 3. And then you're going to take the original number that you came up with and subtract the number that you're working from. Subtract that original number from that number. So pick a number, multiply by 3, add 6, divide it by 3, and then subtract your original number. Now, having done that quickly, that is, you picked a number, you've multiplied it by 3, you've added 6, you've divided by 3, and you subtracted your original number. Now, although the hundreds of people participating in today's conversation have likely picked hundreds of different numbers, I would imagine some of you picked 0, some of you picked 3, 7, 5, and 10. Those are very common numbers. However, the balance of those people have picked different numbers. And if you picked a number, you've multiplied it by 3, you've added 6, you divided 3, and you subtracted your original number, you should get 2. Now, if you didn't get 2, that's okay. The Omega Psi Fraternity Incorporated, the Tau Iota Chapter, is here to walk you through that whole process to ensure that you can get to the number 2. But your number should be 2. And that should demonstrate that we're now all on the same page. My point of adding this exercise to this conversation in comparison to our first 10 days ago was because we're all on different pages, right? Different individuals in your family, different families, different races, different cultures, different cities, states, governments have different opinions on this vaccine. But it makes sense that I think that we would come together as one initially on the same page. And we've done that because if you haven't come up with 2, go back and go through it. Give us a shout out at Tau Iota if you need to understand how we got to the 2. But nonetheless, we're all on the same page now. Now let's take this mindset. We ask that you maintain an open mind, optimism, not pessimism, positivity, not negativity, so that we can get through the conversation appropriately. And now that we're on the same page, I thought that we'd talk about a couple of things. One, Operation Warp Speed. That is, how was the U.S. able to come up with a vaccine so quickly without jeopardizing quality, safety, efficacy? And keep those 3 in mind. I'm going to keep talking about quality, safety, and efficacy. And also, without skipping any steps. You see, number 2, we'll talk about the 3 vaccines, 2 of which are available in our country right now. And I'll introduce the 3rd in just a second. I'll talk about monoclonal antibodies. We're often asked the question around, the so-called cocktail that President Trump received and how he was able to do well. So I thought I'd talk about that. People always ask about supplements or until they get the vaccine. And if I sound biased about the vaccine, it is certainly strategic or intentional because I am a proponent of the vaccine, just as Brother Jones and our bosses and many members of our fraternity are as well. So we'll talk about supplements, zinc, vitamin C, vitamin D, melatonin. We'll talk about proper masking, and then our bosses will open it up for Q&A. Before we get started, though, I thought we would just spend a little time talking about a record that was broke this time this year. So, 2020 is deemed to be the deadliest year in all of U.S. history. Why? Because the deaths have topped 3 million for the first time ever. 3 million people have died already, as you know, because you watch Fox, CNN, MSNBC, your local news. Over 3 million people have died. That has never happened before. Why has it happened this time? Because of COVID-19. Over 320,000 of those additional deaths are secondary to COVID-19. And this slide is probably about a week old. Over 400,000 deaths, that is 15% greater than we saw in 2019. The largest percentage increase since 1918. If you've been paying attention to the conversations that have been taking place around the pandemic, the virus, and the vaccine, the Spanish flu of 1918 did not demonstrate this many deaths. So we have a problem. We have a very serious problem. And when you do the math and you do your division you understand completely that the majority of people relative to the population percentage of the people are people of color. So that's why this conversation is so germane. That's, excuse me, that's why it's so important for all of us to participate. So let's talk about, just for a second, the hesitancy. You know, I've had multiple conversations with many people spanning from the Midwest all the way to the Northeast down to the Southeast. These are either my family members or fraternity brothers. And this hesitancy is real, right? And so you guys remember President Clinton, when he introduced, or apologized, I should say, for the misbehavior of the U.S. government around the Tuskegee Institute syphilis study, right? Either people were exposed to purposefully or knew that they had the diagnosis of syphilis, but they were not told either of the two, and they were not treated, although a treatment was available. And what they were doing, and this is what Brother Jones alluded to in his presentation, thanks a lot for that, Brother Jones, what they're alluding to was the fact that people knowingly had syphilis and they did not consent them to do a study. And they sat back and watched to see what would happen to those infected by syphilis, which is never a good thing, right? That doesn't take place anymore today. So for all of you who, and I hear this, and we have these conversations as a fraternity 2 or 3 times a week. I hear this very commonly. Well, what about the Tuskegee study? Realizing it started in the 30s and went through the 70s. So you're talking almost 50 years of misbehavior by the government. I totally understand that. And we are not asking you to forget about yesterday. We are not asking you to stop looking in the rearview mirror, but what we are reminding you of is that this is the most transparent this government has ever been as it relates to a medication. What do you mean by that, Eadie? Okay, so here's what I mean. Reggie Eadie takes a high blood pressure medication every single morning. That's the one prescribed medication I take. Well, I also take an inhaler whenever I'm wheezing and things of that nature. But nonetheless, every single day, regularly, I take a blood pressure medication. If you asked me, if you dropped into the chat, ask Eadie to give a 5-minute, not 30, but 5-minute presentation on the blood pressure medication he takes, my response is going to be, I can't, because I've never spent a lot of time researching it. My challenge and argument and pushback to all of you who refer back to that is the following. One, you probably can't tell me anything about the medication that you take every single day either. This is the first time in American history that we can all, and if you don't know a lot about this virus or the vaccine, if we do this successfully as fraternity, you will know by the end of this conversation. So let's assume that you will know by the end of this conversation. You've never known this much about a medication. Never, ever, ever. In American history, maybe some of you have because you're in the scientific space or you're in healthcare or you're a pharmacist. I get that, but I'm not talking about you. But the vast majority of Americans, regardless of your skin color, know very little about the medications they take every day. If that doesn't convince you, let's just talk about the meal you ate yesterday. What did you know about the meat you ate? What farm did it come from? How long was it on that farm? What was it fed? What about the water you drank or the juice you drank? Like, I would argue that you know very little about that as well. And that is not to debate your intelligence, but instead is to suggest that today, when we have anywhere between 3,000 and 4,000 people dying every single day, not per year, every single day, you just saw the stats on the last slide. And relatively speaking, the majority of them are people of color. This is probably not a good time when we have an alternative, when we have a solution, a resolution to this pandemic as it impacts disproportionately people of color. It's probably not a good time for us to push back unless you have a better alternative. I have read multiple magazines. I am sent, you can imagine, text messages, jokes, emails, phone calls because of my position on this vaccine every single day. So you can stop sending them, or I welcome you to send them. Keep them coming, but you know what my response is going to be. My response is, unless you have a proven, scientifically proven alternative for the vaccine, I'm going to need you to sit back, stand down, and relax a bit. Because when I see the number of people, whether they're of color or not, dying every single day, and you just say do not take the vaccine and can't provide a scientific reason for it, with all due respect, then I think that you're ending up doing more damage to me and my family and people of color and people across America than you otherwise would, because I don't think that you're giving good advice. Now, hopefully by the end of this conversation, we will convince you. We're very sensitive to this couple that stood right at President Clinton, Henrietta Lacks. Henrietta Lacks clearly was well known to people who researched her over the last 10 to 20 years. But prior to that, and someone who went to medical school and was very familiar and was questioned via test questions on the HeLa cells, I had no idea that there was such thing as a Henrietta Lacks. I had no idea that the HeLa cells that scientists have been using since she was diagnosed with cervical cancer and have been contributed to the longevity of many people in this country and across the globe was related to or from the cervix of a woman named Henrietta Lacks. They didn't teach me that. They forgot to mention that when I was in medical school. So with all due respect to those people who used her cells, shame on you for not notifying her or her family, not consenting her to allow her cells to be used in science. No different from Tuskegee. So we totally understand that. And then the left lower quadrant of this slide is just to let you know that we are very sensitive. And Brother Durkin, you bring this up all the time about our fraternity brothers, friends, and family who are suspicious around those three incidents. And then there's this microchip. And so as you push back on me, because you need to be armed with the intelligence on how to respond to our fraternity brothers, I say to you today, Brother Durkin, that if the U.S. government wanted to put a microchip in something that we would either be injected or ingest, why would they wait until the vaccine came available? They could put microchips in our Cheerios and our potato chips and our soda pop and our burgers. They can control it just to that degree. And so I think it's just not a good idea for us to think that because this 5G narrative and this microchip narrative is coming from somebody somewhere who probably has no scientific proof, that we should not listen to it. Until proven otherwise, it is my position that this vaccine is the best approach for us. When we talk about overall hesitancy around this vaccine, the top three things, and we do a lot of research. As you see, we've done this in the past. You took a poll at the beginning. Please don't forget to take the poll before you disengage with this conversation. But the top three causes of hesitancy in communities of color or communities across the globe, to be frank, one is the speed of the production, so we'll talk about that. The efficacy, as Brother Jones alluded to, we'll also talk about that. And then, of course, the safety of the vaccine. So those are those big three again, right? It's the productivity, quality, efficacy, and safety of the vaccine. The ultimate goal, ladies and gentlemen, is for us to reach herd immunity. So what is herd immunity? Here's the scientific definition of herd immunity. It's the immunity or the resistance of any infection. Obviously, today we're talking about the COVID-19 infection. We could be talking about chickenpox, which most of us participating in today's conversation unfortunately had the experience of being exposed to. I reflect on the time when my mother and grandmother, because somebody in our family or somebody in our household or in our school was diagnosed with chickenpox, we were forced to be exposed to those kids. Why? Because although they couldn't describe it at the time, they wanted herd immunity. Somebody had the wherewithal to say, expose all the people you can so that we can control things like the chickenpox until a vaccine becomes available, which it is today, and many kids take it. Prior to that, kids didn't always do good once they got exposed to the chickenpox. Now, so it's the immunity resistance of an infection of a group of people. And we're not just a group of people. We need the vast majority of individuals so that we can reach herd immunity. And there's two ways to reach herd immunity. One is through vaccination. Let's put that to the side. The other is through a previously exposure to the infection. Now, why will that not work? Well, that's not going to work. You already know why. Because the number of people that get infected with COVID and die, particularly people in the African American or communities of color, is at a higher rate than any other community on the planet. We cannot afford to get herd immunity by exposing people to COVID-19. So again, unless you have a better alternative, when you tell people not to take this vaccine, or when you try to convince yourself to not take this vaccine, what's the alternative? You know what the alternative is. You see it every single day, everywhere you go. It's death. And every single day, unfortunately, either at one of the hospitals that I work at or through a friend or a family, someone's either getting exposed or infected or they're dying. And I don't know about you, but I can't take that anymore. So at some point, we have to stop this. We have to disrupt this path that the enemy has placed us on. And again, the vaccine. Okay, that's my passion. Those are my emotions. I'm going to speed up now. I'm going to get a little scientific. So please stay with me. We're going to talk about Operation Warp Speed. So Operation Warp Speed, we first heard about it, I think, for the most part, when the President of the United States named it Operation Warp Speed. Now, when the President named it Operation Warp Speed, that didn't really mean much to me, because what I do remember and understand and appreciate is that the President has nothing to do with the production of this vaccine, right? It's companies like Pfizer and Moderna and AstraZeneca and Johnson & Johnson, not the President. Now, the President will appoint someone who oversees the government's engagement of the production, distribution, and administration of this vaccine. And I am not trying to pick a political fight with anyone and sound like I am opposing the president. That's not my intention here, as our boss list opened up with. But instead, the facts are the facts. When we talk about this vaccine, it has nothing to do with the White House. It has to do with the companies that had the technology to produce it. Well, let's talk about that in just a second. But nonetheless, their mission, which I will call a vision, their mission was to deliver 300 million doses of safe and effective vaccine by January 1, which is right around the corner, right? Literally days away. So what you should also know is that the typical process to produce a vaccine is about 73 months. So about 6 years to produce the vaccine. This accelerated vaccine process, they forecasted would take about 14 months. Now, clearly, the vaccine didn't come into our lives until the end of February. So let's just say February 1st. Here it is, December. So we're talking about the 12th month and the second month. So 10 months later, we have a vaccine. And they forecasted 14 months. So we've actually beat not the number of vaccines that are available, but nonetheless, the time in which it would take. All right, so let me finish this slide by dropping you down to the base of this slide. You see a legend there. You see colors. The blue, and I'm going to give you a few definitions, so please get this. The dark blue represents the research and development or the preclinical trials. When we talk about preclinical, when you read about or hear about the word preclinical, think to yourself animals. When you hear clinical trials, think to yourself humans. Preclinical animals, clinical humans. Oftentimes, we hear about preclinical trials, including mice. When it comes to things this serious, like a vaccine, they oftentimes include animals like the chimpanzee. Why the chimpanzee? Well, because the chimpanzee is 99% or one chromosome different from being a human. So that's why they want to pick an animal that's the closest to all the people on this line. As the colors or the blues get lighter, we go to the phase 1 clinical trials. So phase 1 clinical trial, clinical means humans. Phase 1 means there's less than 100 participants. Phase 2 clinical trials, we're going to the next lighter blue. The phase 2 clinical trial, I'm at the bottom of this slide. The phase 2 clinical trial suggests that there are hundreds of people. So phase 1, less than 100, phase 2, hundreds. Phase 3, we get into the thousands. And then you see the dark brown means the manufacturing, the production of the vaccine. And then you see the orange is the distribution. Let's go back up to the typical process. You see 3 months for the preclinical trial with the chimpanzees, 5 months with less than 100 people, 21 months with hundreds of people, 23 months with thousands of people. And that's phase 1, 2, and 3. That's important. We'll get back to that. Because once you're done with phase 3 of the clinical trials, then you ask for permission or approval from both the FDA and the CDC, which you've been hearing about. They've been doing a lot of work on weekends. Once they give the thumbs up that this vaccine is what? Safe, effective, and of high quality, Then they go into manufacturing, massively producing the vaccine. So that's 15 months. They can go into distribution throughout the states of the country so that they can inoculate or inject it into people, and that's 6 months. So that's why it takes, on average, 73 months to produce a vaccine. Now let's go down to the accelerated process. This is one of the most important points you need to convince yourself of. And I am not making this up. I promise you, if you did a Google search on Operation Warp Speed, you will either see this exact slide or you'll see some language supporting or summarizing this whole process. So this is not, none of this is a Reggie Eadie or a Greg Jones or a Mega Sci-Fi or Basilis Santana opinion. This is science-based. I will let you know when it is at least my opinion. The accelerate process, you see they took the dark blue and the first lighter blue. So they did the research and development and the phase 1, remember, less than 100 people. They did that in 5 months. The normal process takes 8. Then they moved over to phase 2 and phase 3, which typically you see in the typical process would take 44 months. They reduced that down to 6 months. And then you see the manufacturing went from 15 months, just over a year and 3 months, or just a year and 3 months down to 0 months. Why? Because they did it all around the same time. Remember, the pandemic started in February. This new RNA that we're going to talk about in just a second, that you're going to be very comfortable with explaining to yourself and others, this new RNA process existed prior to the pandemic's onset. This mRNA process was used to create a vaccine, was being studied to create a vaccine for cancer and a treatment or cure for cancer. When the pandemic hit in February, they stopped the line. They transitioned, that is, they being, by definition, because, you know, they say doesn't really mean anything to any of us. They equals Moderna, Pfizer, Johnson & Johnson, AstraZeneca, et cetera. Not the US government, not the president of the United States. They started massively producing this vaccine because they literally had people every single day raising their hand saying, you can use me in the study. I'm willing to participate. And where's my vaccine? To the extent that vaccine didn't exist, then they had a failed participant. So they started massively producing this vaccine way before they finished phase 3 and got approval. Now, some ask the question, well, why would Pfizer do that? Well, Pfizer would do it because they believed in the technology that existed. And if they completely understood from a business perspective that if they did not get approval, those were millions and millions of dollars that were wasted and could almost possibly flip the company upside down. But they trusted the science and they believed in it. Plus, ladies and gentlemen, people were dying by the thousands every day, and we needed a solution to the pandemic. So after the 15 months went to 0, then the distribution, which you guys are well aware of, you saw the last 3 and 4 weekends that literally there were trucks outside of airplanes loading up Pfizer and then Moderna vaccines ready to ship them to our respective states. So long story short, the reason why they were able to accelerate the production of this vaccine is not because they skipped steps. It's not because they jeopardized the quality, the efficacy, or the safety of the vaccine. Instead, as you see in the typical process, instead of doing things in series, step-by-step manner, they did things in parallel, simultaneously, at the same time. And they were able to do that only because we were in a pandemic. They didn't skip anything. It doesn't mean that the vaccine is unsafe. They did the same thing they would otherwise do. They just did it all around the same time. And that's why we have a safe, effective, and high-quality vaccine in the United States today. All right, so let's talk about an analogy. So now what I'm about to talk about, and if you have questions about that, please drop it in the chat box. And look, I'm a big boy, so just push back, charge and challenge me. I will hold myself accountable as you do for anything that I say and I believe in. So now let's talk about, in an informative analogy, how the COVID-19 virus, the RNA technology, and the vaccine works, right? So let me start with this analogy. So let's assume my wife sent me to the store, let's say IKEA. She sent me to IKEA to get a new kitchen table. Let's just say the kitchen table that we currently had broke. So she sent me to IKEA to get a kitchen table. I go into IKEA, I get the big, long, rectangular 4-wheel cart with the big square handle. that never pushes forward. So you always have to readjust it. You know what I'm talking about if you've been to IKEA. But nonetheless, I grabbed a big box. That is the exact kitchen table that my wife sent me to IKEA to purchase. So I put that on the cart. When I get to the register, I have a conversation around my choices. Do I need to take this big box home and spend hours, because I'm not a handyman like Brother Bosselus Joe Santana is. He does a great job and stuff like that. He's the handyman if you guys need any help. But I'm not that guy, right? So I asked the people at the register, can I just pay you to assemble the kitchen table? They say yes, and they give me the fee. So I pay for the kitchen table. I pay for the assembly. Then they take my box to the back of IKEA where the assemblers, let's call them the assemblers. These are people who put the box, who put the ingredients in the box, the contents of the box together. So the assembler opens it up. There's this manual on how to put it together. So this instruction manual is at the top of the box. The person who's much better than I am from putting things together, equivalent to our bosselist. So the assembler goes through the instruction manual and follows the instructions and puts together this table. After which they then give me the table. I take the table outside of IKEA, load it on my truck. I take it home. I simply carry it in the house, put the tables on the outside, and we have a new kitchen table. I get all the credit for it, but it's really the assembler who did the work. Now, for the sake of the next slide, for comprehension purposes, let's say that this red circle resembles everything that happens inside of IKEA, right? All right, so to the extent you understand that analogy, which I'm sure I'm not the only person out there who has to pay to get things assembled, to the extent you understand that, you're gonna understand completely how COVID-19 works, how RNA works, this new technology, and then how the vaccine works. But before we go to this slide, if anyone participated in any previous conversations that we had, you remember I didn't use an IKEA store analogy. I used a Costco analogy. And then Brother Greg Jones's daughter reminded me, or reminded him to remind me, that Costco doesn't really have these big boxes with these kitchen tables and these long rectangular four-wheel, can't push them straight carts. So she recommended that I use IKEA. So I just wanted to quickly say thanks, Morgan Jones, for for the observation and advising me, just as your father does all the time, on the right thing, the right way to do things. So thanks, Morgan. All right, so let's keep moving. So kitchen table assembly at IKEA. Now this red circle is, I'm reiterating what I just went through. In the event that someone is listening very closely, like Morgan was, and has some recommendation, because this is not about our fraternity. This is not about our boss. This is not about Brother Jones. It's not about me. It's about you having the knowledge that you need to make the right decision. All right, so we're at IKEA. This red circle is everything that happens inside of IKEA. Remember, I bought a box, put it on the cart. Inside the box was instruction manual, parts, and tools. I took it to the register. I paid for it. I paid for assembly. They took the box to the back. The assembler read the instruction manual, gathered the tools, the parts, put it together. We left IKEA. We took it outside of the store. This assembled table, I put it on my truck, and then I then took it home. Now, remember, the box, the assembler, the final assembly of the table is just that outside of IKEA. Now, to the extent you understand that, let's go to cell reproduction and replication. Now, the red circle now does not demonstrate what happens inside of IKEA. Instead, demonstrates what happens inside of your cell. So that's a human cell. Remember, the DNA is now the box. The DNA is equivalent to your instruction manual. The DNA is your genetic code. So substitute box for DNA. Let's move over. Next is the RNA. Remember, the RNA is equivalent now to the assembler. The RNA, just like the assembler, follows the instruction manual, which is now the DNA, and it puts together whatever the DNA or the instruction manual is guiding it to put together. And then outside of your human cell, let's say now in your bloodstream, whatever it produces, it dumps it in your bloodstream, and that's equivalent to the final kitchen table. Now you got that. DNA now is a box. RNA now is the assembler. The final product is equivalent to the final assembled kitchen table. So now you know what DNA does, it's the instruction manual. You know what RNA does, it's the assembler. The final product outside of the cell in your bloodstream is the final product that it produced, which could be a protein, it could be another cell exactly like itself, it could be any of those things, but nonetheless, it releases the final product based on what the instruction manual of the DNA told it to produce. We know who produces the assembler of the RNA, and it dumps into your bloodstream. All right, so let's talk about how the coronavirus, and it needs the human cells to replicate. If you guys had participated or paid attention to back in February, March, and April, or participated in one of our fraternity's conversations, you knew that the coronavirus cannot exist unless it is exposed to a human cell. So what does that mean, Eadie? So you remember the conversation we had about fomites. You saw on the news, you read in the paper that the coronavirus may exist on your keyboard, your steering wheel, on the box that Amazon delivers on your porch, the food that's delivered to your home for only a few hours. The reason why it would eventually die off is because it has to have the human cell in order to have the energy, the nutrients, the ability to not only exist, but also to reproduce itself. Meaning one coronavirus would just die off unless it has access to a human cell. Once it has access to a human cell, it's going to produce 2 coronaviruses, and then 4, and then 8, 16, 32, and so on. So let's go through this. Look at the top left corner of the slide. You see the parts of the coronavirus. You know that illustration oh so well. You see that there's a lipid membrane, so that's the outer layer of the coronavirus. You also see that there's an envelope protein. You see that there's a membrane protein. Now, all those proteins, remember we talked about your cells produce proteins. All cells, like the coronavirus cell, produces proteins as well. Now, then you have the spike protein, which I would love for you to pay close attention to moving forward, because this really is the crux of the matter and the second most important point that you're going to take home. It's the spike protein. They call it a spike protein because under a microscope, ladies and gentlemen, when they look at it, there's this thing called the stem of this protein, and then it has what we call a crown. Under the microscope, that thing that looks like the Y looks like a crown. Another name or a scientific name for a crown is a corona. Hence why they call it the coronavirus, because they look under the microscope and it looks like this virus, this circular virus that has these crowns coming from it on the end of the spike protein crown. And then on the inside is the RNA. So you see that white squiggly worm-looking line, that's the RNA. You know what RNA does. RNA is the assembler. It's what follows the instruction manual or the DNA and produces something. So now you completely understand how this coronavirus works. This coronavirus has to have access to one of your human cells. Once it attaches to your human cell, and remember, it has to attach to one of your human cells. Once it attaches to one of your human cells, you've got the spike protein and you've got the crown or the corona. Once it attaches to one of your human cells, look at my hands, it attaches to one of your human cells, it punches holes in your human cell. And that's the illustration, that's what the illustration is trying to show. It attaches to one of your human cells, it punches holes for one reason only, and that is to deposit the COVID-19 RNA in your cell. Now, it's RNA. RNA all does the same thing. Now, earlier we talked about what your RNA does, but once that coronavirus attaches to your human cell, punches holes and deposits its RNA in, then you know what RNA does. RNA produces or assembles things. So once that coronavirus has access to your cells, it punches holes, it deposits RNA. What is it going to produce? Another coronavirus. That's how you go from 1 to 2, 2 to 4, 4 to 16, 16 to 32, and so on and so on. So right now you should be thinking about many things, right? You should be thinking about the hesitancy that exists in the community. You should be thinking about the analogy that we just went through from IKEA. You should be thinking about now how the coronavirus works once it gets into your cell. And you've got to be asking yourself the question, well, how does it have access to my cell? Because if it never has access to one of my human cells, then I don't have to worry about the coronavirus. And then the thousands of people that have died, that die every single day, if they knew this and could prevent it from attaching to one of the human cells, they just might be alive. And 2020 won't be the most deadly year in the history of mankind that we've ever experienced. All right, let's keep going. So let's talk about how the vaccine works. So let's go back to this red circle, which otherwise was IKEA, but now it's a human cell. And then you've got the coronavirus. Now we're talking about the vaccine, not how the coronavirus works. You just went through that. The coronavirus grabs a hold of your human cell, punches holes, deposits RNA, and produces another coronavirus. This is how the vaccine works. So let's just think about this for a second. The very first step for the coronavirus to infect one of your cells is to have access to it. And once it has access to it, it grabs it, punches holes, and deposits RNA so that it can replicate or reproduce or go from 1 to 2, 2 to 4, 4 to 8. So let's take a step back. So how in the world does the coronavirus have access to one of your cells? Well, you already know the answer to this question. We know based on, in comparison to what we did not know back in February and March, that the most common way that the coronavirus has access to human cell is because it's in the air. It's aerosolized. Therefore, we also know that the most common way it has access to one of your cells so that it can grab onto it, punch holes, and deposits RNA is through your nose or your mouth. Therefore, if we want to prevent the most common way that it has access to a human cell, we have to come up with a way to prevent it from going into your nose and your mouth. And what we've done is advise you to wear a mask. The mask, when worn properly, let me underscore that. When worn properly, we'll talk about that as Brother Jones alluded to in just a second. It will prevent this aerosolized coronavirus from entering into your mouth and your nose. Now, some people are smart enough to know that although it's very, very, very rare that it has access to your cells from your eyes, it could also, in rare occasions, and I underscore rare occasions, it can have access to one of your cells through your eyes. And that's why people wear face shields in addition to the mask. Please don't think wearing a face shield with the bottom of the face shield being wide open that you're protecting yourself, because the most common way that the vaccine has access to human cells through the nose and the mouth. So if you're wearing a facial mask without a facial shield without the mask, it's not, because that's a very rare occurrence as to how it can have access to human cells. All right, let's go back to the vaccine. I just wanted to cover that very quickly, and we'll come back to that if you missed any of it. So how the vaccine works. So we're talking about the vaccine. Scientists, as I indicated 4 or 5 slides back, have been working on a messenger RNA or an RNA technology for cancer. What they did was they took the coronavirus, they pulled out the RNA. You remember that squiggly line on the previous slide, right there, top left corner. They took the RNA out of the coronavirus. They found out which part of the RNA was responsible only for the COVID spike protein. So they looked at the entire RNA, which, as you saw by that previous picture, it can produce an entire coronavirus. They then took the coronavirus, opened it up, took out the RNA, and then only took the part of the RNA. They cut out the rest. Only took the part of the RNA that was responsible for the spike protein. And when they did that, they were comfortable that they had an answer to the problem. So spike protein from RNA from the coronavirus, they then took just that piece of the RNA, which that's the spike protein. That's what they inject into your human cells. Once they inject just the RNA that's responsible for producing the spike protein, get that, not the whole RNA, because if they injected the whole RNA, they would be injecting the coronavirus inside of you and you were producing more coronaviruses. So they pulled the RNA out, found the RNA, this is science, only responsible for the spike protein. They inject that into you. It's RNA, so you know what it's going to do. It's going to produce more spike proteins. And once you produce more spike proteins after you've been vaccinated, then you produce, this is the spike protein with the crown, you produce what's called an antibody to stop it. Now think about that for just a second. If the way that the coronavirus, and I know I'm repeating myself, so thank you for being patient. This is just so important, and I want to make sure that we dispel the myths, the narratives in the community and on social media that are discouraging a lot of us from taking the vaccine. We're not injecting the coronavirus. They're not injecting coronavirus inside of you. They're only injecting a part of the RNA of the coronavirus. You know how RNA works. It's the assembler, so that you can start producing in your blood, outside of your IKEA, more spike proteins. Your body sees that spike protein as a foreign object, as you see on the right side of the middle right side of this slide. It produces antibodies to prevent it from attaching to your cells, punching holes in deposits in RNA. You know that's the very first step on how the coronavirus infects a human cell. So we can stop the very first step, then we can stop the infection of the coronavirus into the human or the human cell. And that's how the vaccine works. Here's another illustration, which you would probably, when you Google to test that we're telling you the truth after this conversation, you'll probably see this is a very common slide, which says the same thing, right? The coronavirus in the top left corner, you see the RNA. They inject only the RNA, that's the vaccine, into your muscle. Your muscle then produces spike proteins. Your body produces antibodies to the spike proteins, and it prevents it from infecting your cells or reproducing. Now, that technology I just described is the most common reason why people are hesitant. That's the technology that only Pfizer and Moderna uses that I know of so far. AstraZeneca and Johnson & Johnson don't use this technology to my knowledge. So I wanted you to be real clear on this new technology from an RNA perspective. That's all you need to know. So convince yourself, or at least educate yourself. Whether you convince yourself or not is up to you. But when people bring up the subject matter around the hesitancies and this new RNA, be responsible enough to the extent you believe this, and please do your own research outside of our fraternity. Be responsible enough to tell them how they were able to quickly produce it. This RNA technology already existed. It was not new. It was used for cancer. They did not skip any steps. They didn't jeopardize quality, safety, or efficacy, and they were able to produce it, thank goodness, in a short period of time. All right, so let's talk about the 3 vaccines. I'm going to speed up here because we're running out of time. So we've got the Pfizer, the Moderna, and AstraZeneca. Now, when you look at this spreadsheet, you completely understand what they're talking about in the media. Pfizer and Moderna, they're both RNA-based. You see, AstraZeneca is a live attenuated adenovirus plus a spike protein RNA. So it looks like AstraZeneca is different from Pfizer and Moderna, and this is what you need to know, because AstraZeneca is going to be available very soon at a hospital or pharmacy or doctor's office near you. AstraZeneca is different from Pfizer and Moderna, which are already available, and some people in this line have probably already had the vaccine. Pfizer and Moderna use that technology of injecting a part of the RNA that produces the spike protein. You see on the right column, AstraZeneca uses spike protein RNA, but it also adds a live, attenuated, meaning weakened, adenovirus. The adenovirus is what causes the common cold. So what AstraZeneca did, before they took the new technology, they went to the chimpanzee, remember? Preclinical trials. They found chimpanzees that had common colds. The common cold is caused by adenovirus. They removed the adenovirus from the chimpanzee, and you know why they use a chimpanzee in the preclinical trials, because the chromosomes are very similar to humans. They removed the adenovirus. They injected inside the adenovirus the piece of the RNA responsible for producing the spike protein, and then they start injecting that into people. You saw from the second video, Brother Corey Harwell, he didn't have Pfizer, Moderna, or AstraZeneca. He's a part of the study for Johnson & Johnson. So that's a total different study. I'll be adding a 4th column when I learn more from Brother Harwell about the Johnson & Johnson study, so that the next time Omega Psi Phi Fraternity Incorporated Tau Iota Chapter has this conversation you participate in, you can completely understand that, because you are going to be faced with choosing, in some cases, not all, depending upon availability, Pfizer, Moderna, AstraZeneca, or Johnson & Johnson. What are the differences? Pfizer, you take 2 injections, 21 days apart. Moderna, 2 injections, 28 days apart. So Pfizer's 21, Moderna's 28, and then AstraZeneca is 30. So 3 weeks and a month, essentially, is all you need to remember. Then there's the efficacy. The efficacy. How effective is each of those 3 vaccines? Efficacy just means that of the number of people vaccinated, and under Pfizer's situation, it's 95%. So for every 100 persons that were injected with the Pfizer vaccine, 95 of those 100 people, or 95%, developed a full immunity. 5% did not, but I'll talk about the good news about those 5% in the event that any of us are in that 5% if you get the Pfizer vaccine is concerned. Then Moderna had an efficacy of 94%. You see AstraZeneca, and if you've read the details, and I won't bore you with them, the efficacy is anywhere between 62 and 90%, on average at 70%. So, and you see the next line, spike protein. They all use the spike protein technology. So let's drop down to the green box. What I wanted to show you here was that everything above that, although the narrative says this is all new, don't trust it, it's the devil's or it's the white man's vaccine. And Brother Jones did a good job in explaining to you the difference between science back then in the 30s and the Tuskegee Institute studies and today. Then you do not have to take it. By law, they have to expose you to it. And as a fact, you know more about this vaccine, again, than you know about any vaccine that you've taken. Look at the flu vaccine, which many of the people on this line, there's hundreds of people participating today. And I would imagine that the average age, I would guess and say, is 45 or above. So if you're not taking the flu vaccine, since the flu does kill, although it doesn't kill as rapidly or commonly as the coronavirus, it does. You've taken the flu vaccine. Probably 100% of us have taken the MMR vaccine. That's the measles, mumps, and rubella. So let's look at the 2 of those and then compare it to the Pfizer, Moderna, and AstraZeneca vaccine. So the flu vaccine, it's an annual shot. People always ask, well, how often we have to take the vaccine for corona? We don't know that yet, but we'll learn very soon. So it's an annual vaccine, and the efficacy is 50% between 40 and 60. Remember, Dr. Fauci said, if we can just get a vaccine that is 50% effective, the efficacy is at 50%, I'm good to go. What you see is 95, 94, and up to 90% for those 3 above. Much better than the flu vaccine. The reason why the flu vaccine's efficacy is a little lower is just as you imagine, it's because of mutations, right? The flu vaccine, there are thousands of viruses that fall in the influenza family that can cause the flu. Now, we may get there eventually because you're hearing about mutations, and I'll talk about that in just a second as I wrap up for the coronavirus, but it's no concern of yours right now, and the vaccine is effective against it. I realize I'm answering questions, so hopefully that helps. Let's look at measles, mumps, and rubella. It is also a live virus. It's just been attenuated. So the flu has been deactivated. The MMR, the measles, mumps, and rubella, has been weakened. Unlike the Pfizer and the Moderna, those are not live viruses. So I don't want you to think that this is so much unsafe than anything you've ever had. And again, we want to dispel some of the narratives that are going out causing hesitancy, anxiety, or fear around this vaccine. Remember, what is the alternative? If we don't take this vaccine, we can forecast, predict with 100% certainty what's going to happen. People will continue to die. Thousands every single day. And relative to the population, the majority of them are going to be people of color. You see MMR, measles, mumps, and rubella, had an efficacy of 97%, which is better than Pfizer, Moderna, and AstraZeneca. So this is not new stuff. The RNA technology is new, but this is not new information. You've already been exposed to this, and you need to just understand that you've already been exposed to these types of very similar vaccines in the past, which you knew nothing about. Today, you know more about these new vaccines than you did in the past, and you didn't complain about the past. You just rolled up your sleeve as your mother told you to, or your teacher or the school system told you to, and you're doing just fine today, right? There's no evidence that the flu, the measles, mumps, and rubella vaccine has created deleterious or poor outcome. And I'm submitting to today that there's no evidence that these will either. A couple other things that you should know about these these three, but particularly about the Pfizer, right? So the Pfizer vaccine was not administered to people who were under 16 years old. Certainly, it was 13 and above, and all those that have participated. Also, there was very few people between the ages of 16 and 17. If you remember, there were 4 pediatricians when they voted to approve the Pfizer vaccine, which is the very first one. The 4 pediatricians voted no, so they made up 20% of the people that voted. So 80% voted yeah, 20% voted no. The reason why those pediatricians voted no, because they just didn't want to include the 16 and 17-year-olds, not because the quality, safety, and efficacy of the vaccine. They said it was not enough people in the study who were 16 and 17. Let's just start at 18. They got approval for 16 and above. So that's one thing you may want to consider. Does a 16 or 17-year-old today, although they're not likely to be exposed to the vaccine at this point, they won't qualify, should they take the vaccine today? So that's and I'm being transparent. I'm addressing all the gray zones. If you ask me, should a 16, 17-year-old get it today? I would say, well, let's do some more research and figure that out. But certainly 18 and above, where there were thousands of people, because you see in that purple circle in the left lower quadrant, there was only about 153 people between the ages of 16 and 17. So that's, remember, phase 1 clinical trial, less than 100, phase 2, hundreds. That's only phase 2. Phase 3 is thousands. Those 4 pediatricians may have voted yes. There are thousands of people between the ages of 16 and 17. No pregnant women and no women that were lactating. So that's also something for you to consider. Now, the good news about the efficacies not being 100% is this. Of the people on Pfizer that fell in that 5% category, or Moderna, that 6% category, none of them got so sick they need to be hospitalized. And what percentage of them died? 0%. 0% died. So even though they didn't establish a full immunity, like the 95% of the people from Pfizer who got the injection, they still did very well, and they didn't die. And we think that the crux of the matter here is to reach herd immunity, so we no longer have anybody dying from this coronavirus. I'm often asked about the demographics of people who participate in the Pfizer study. This is just Pfizer. You see half were female, 9% were Black, 26% were from the Latinx community, which I believe is something to be very appreciative of. Why? Because, I mean, in Connecticut, where many of us who are hosting tonight's conversation live, we're only about 6-7% of the state's population. For America, we're about 12% of the population. So 10% or 9% is not bad. The Latinx community, 26%. Of those who participate in the study, this is the research, the study, because this is the question we're often asked. How many of those are 65 or older? The answer to that question is 21%. How many were 75 years old or older? The answer is 4.3%. The average age, you should know, is 51. And then there was the question, and remember back in February, people were saying, first of all, we were saying the narrative was that if you're Black, you don't have to worry about corona, which couldn't have been further from the truth. So that just goes to show you that social media junk, it's not factual oftentimes, or sometimes I should say. Those are just basic factoids. They're not facts. And we shouldn't just follow them. We should parallel them or compare and contrast them to the science before we make an intelligent decision, as our boss was alluded to. Next was that first, you were Black and you weren't going to die. Second, if you were obese, overweight or obese, then you were surely going to die. If you had lung disease or immunocompromised like diabetes, then you were going to die as well. So what Pfizer did, which was intelligent, 35% of people in their study were obese, 8.4% were diabetic, 8% had known lung disease, because remember, people that died from lung disease, pulmonary disease. They needed a ventilator, and oftentimes if they needed a ventilator, they didn't do good. So I think that they created a sample size and a sample of a demographic that convinced me as a scientist that this was the right way to go. Here's even better news. So you know that Pfizer's efficacy from 3 or 4 slides ago was 95%. Below that red circle, you see all the subgroups or explains how they got to the 95%. I just want to underscore one point. I'm not going to get into the genders. I'm not going to get into the age, but because the hesitancy exists most commonly in communities of Latinx or African American, listen, the Pfizer vaccine, and I'm not saying that the Moderna or the AstraZeneca or the Johnson & Johnson won't be the same, but what we do know, based on the the information that was provided by Pfizer and approved by both the FDA and the CDC, 100% of the African Americans, not 95, 100% of the African Americans that participated in the study developed an immunity. Not 95, but 100%. And about 95% of the people from the Latinx community develop an immunity. So you can't get any better results from a vaccine than this. Very quickly, these are the side effects. I'm often asked about side effects. Side effects are real. Let me start off by saying this. When you get your vaccine, if you don't develop side effects, then the vaccine could not be working effectively. So in other words, you want to get side effects. Think about this. So I've had multiple friends, frat brothers who have been, some of them are participating today. I'm not going to call your name up, but you were diagnosed with testing positive for COVID-19. Our conversations revealed that you had a headache, you had muscle pain, you had fevers, chills, nausea, vomiting, diarrhea. And you called me or texted me and said, should I be concerned? And of course, my answer was, yes, you should be concerned. But the symptoms, the side effects that you experience only tell me that your body is working to fight off the virus that infected your human cells. The same thing applies with the vaccine. When you get injected by the vaccine, you should expect to get some side effects, right? You get side effects from your food. You get side effects from what you drink. You get side effects from your prescribed medications or your over-the-counter medications. You do. They may not be that extreme, but you get side effects. So it's important to know if you get the Pfizer vaccine that after your first vaccine, you have little to no side effects. Most of the side effects, as you see here, show up after the second dose of the Pfizer vaccine. And then of all the side effects that one experiences based on the research, people who are 55 years old and younger have very few side effects. I'm sorry, have the majority of the side effects. Those that are 55 and older, which unfortunately I don't qualify for yet, those people experience very few side effects. So the older you are, the less side effects is the point there. You should also know that if you do experience side effects, whether it's after the first or the second dose, they usually are gone within 24 hours. So if you don't believe that, talk to people who have gotten the vaccine, ask about their side effects. Most of the people who've gotten the vaccine has only had one dose. So you may want to ask them now, then ask them after the second dose. And this data is telling you that most of them will say, I had no side effects after the first dose. I had side effects after the second dose, but they were gone within 24 hours. And the majority of people that said they weren't that mild or moderate are going to be less than 55 years old. So one of the things that our fraternity has taught us is not only to talk, because that's what we are and that's what we do for the community, but we should also walk the walk. So that's a picture of me on the 21st of December getting my Pfizer vaccine. The organization that I'm blessed to work for, we had the vaccine for a week at that point, but I decided to wait a week because I didn't want to jump the line, although I qualified for it. But it was important that I went in as soon as possible. As a person of color and as the president and CEO of this organization, my fraternity has reminded us, just as our parents have, that we should also lead by example. So that's me getting my vaccine. What did I experience? Absolutely nothing. My wife touched my arm the second day, and there was some soreness there, but I otherwise didn't even appreciate it. So I'll say I had soreness at the injection site, but otherwise I have had absolutely no symptoms. Now, I don't know what I look like to you, but I look like I normally look, and I feel like I normally feel. So I will tell you that I'm one of thousands of people, millions of people. We've vaccinated over 1 million people. I think the last number I saw was about 1.5 million since the Pfizer vaccine and the Moderna vaccine landed here in America. So we're leading the rest of the world. And listen, if you're concerned about what neighborhood you're getting your vaccine in, because your neighborhood is predominantly a neighborhood of color, then go across town and get your vaccine. If that makes you feel more comfortable, go across town and get your vaccine. But don't just take the position based on your emotions and something you heard or read on social media or amongst your friends who have no scientific support around their decisions. Don't just make a decision that you're not going to get the vaccine and sit back and wait. Because some of us say we're going to wait after other people have had it. Over 1 million people have had it. So what else are we waiting for? I submit to you that the one thing you could be waiting for if you don't get the vaccine now is waiting to die. I know that's harsh, and I hate to be that way, but as a scientist and as a physician and as someone who cares about all the participants in today's conversation, I'm not sure you want to wait. because thousands of people die every single day, and you don't want to be that person. Okay, just a couple more things, Brother Bossis, and I'll be done. So work group considerations. So remember the CDC ACIP subcommittee gave us the definition of 1A. Remember, there are 4 phases in the rollout or the administration of this vaccine. 1A were people that residents in long-term care facilities like nursing homes and people in the healthcare space. 1B are going to be people that are 75 years old or older, and frontline essential workers. And the 1C are going to be those that are 65 to 74 years old, or persons 16 to 64 with a past medical history or comorbidities, and the remainder of the essential workers. So 1B should be coming up in the next few weeks, 1C a couple weeks after that before we get to phase 2. This is just a list of those frontline essential workers on the left. So please peruse that very quickly. And on the right, when we get to 1C, those are the other essential workers. Now, your state has the ability to define who's in 1B and who's in 1C. So it may differ from your state, but these are the recommendations that are coming from our federal partners. And then people are asking about the vaccine, and because there are mutations in the vaccine, in the virus, will the vaccine still work against the mutated viruses? My answer is yes. There's no evidence that it won't be able to combat or create immunity around the mutated viruses. Here's what you need to know, facts. Although the mutations are on the spike protein at the crown, and the vaccine is created just to block or create antibodies against the spike protein and its crown, out of the many components or amino acids that make up this spike protein, amino acids make up proteins, 99% of it has not changed. Only 1% is mutated, and this antibody still can combat the 99%. It won't be until we get closer to 50 or above 50% of mutations that we have to worry about the vaccine not working. And we believe that as long as people participate in this call and across the country and the globe roll up their sleeves, we don't have to worry about mutations. So I wanted to answer that question. And then someone asked a question about monoclonal antibodies, the cocktail that President Trump received. There is something called a monoclonal antibody, and everybody wants that monoclonal antibody once they get infected. There are a couple things you need to know. First of all, the same people that want the monoclonal antibody once they get test positive, like our president did, those are the same people that said that this vaccine, this whole pandemic is a hoax and that you shouldn't take the vaccine. The monoclonal antibody, although it does work and is scientifically proven to be safe and effective, it should raise more concerns to you than the vaccine does. I'm not saying you shouldn't take it, because if I test positive, I'm going to ask for the monoclonal antibody. But the monoclonal antibody was made purely in the laboratory. I want you to know that. It was made purely in the laboratory as opposed to the vaccine, which took the virus, removed the RNA, and you already know the rest. Cut out the piece that's specifically for spike protein. So I just want you to know that. Now, you also need to know that if you test positive, because if you test positive, I want you to have access to the monoclonal antibody. There are 4 characteristics that you must qualify for in order to receive the monoclonal antibody. 1 is you have to have a positive test for corona. 2, you have to present within 10 days of the start of your symptoms. Now, I need you to get that, because oftentimes, especially people of color, because of our hesitancy in healthcare, we don't present till the 11th day or the 12th day or the 13th day. Many of us don't present until we're taking our last breath. You cannot get the monoclonal antibody. So in the event that you test positive, you need to understand exactly when your symptoms started. If you think you're going to need hospital intervention or need the monoclonal antibody, or the Trump cocktail is what people refer to it as, you need to show up to the hospital within 10 days. On the 11th day, they can't give it to you. You also need to be at least 12 years old or older and weigh at least 88 pounds. And then you must be at high risk. So they won't admit you to the hospital unless you're moderately or severely sick. So I would still present to the hospital, because what we did see is that people started dying from the 3 most common causes of death: cancer, stroke, heart disease, when the pandemic started. Because although they were having a stroke or heart attack, because the media said, don't go to the hospital, we listened, and then we died at home. So at home death rate increased significantly in some states based on my research, like Michigan, Connecticut, and California. It went to 30, 40, 50%. So you should still go to the hospital regardless of your symptoms, whether it's COVID related or not. And if you think you have COVID, once your symptoms start, don't wait beyond 10 days to present to the hospital. Why the mask? We talked about this because coronavirus has access to the human cell most commonly through your nose and your mouth. And if it gets into your lungs, that's when people get in trouble. My last two slides are this. Wearing the mask is important. We just talked about multiple times how it has access to your human cells. It's airborne, it's in the air. So you can literally get on an elevator that's empty, but before you got on that elevator, whatever floor the elevator was on, could have had a person on the elevator without a mask on who coughed, spoke, was singing, whatever the case may be. They deposited the coronavirus into the air. They got off, the elevator came to your floor, you got on, you weren't wearing a mask, you inhaled it, and now we got a problem, ladies and gentlemen. So that's why you must wear your mask. If you want extra protection, you must wear, in addition to your mask, your face shield. Now the mask, just not any old mask, is what you should wear. So let's talk about these first 5 people on this slide. The first person, it can get corona very easily if she walks on an elevator, because the most common way you get corona is through your nose and your mouth. She's not covering up her nose. Might as well take the mask off. The next person, let's do the second and the third person. So you see the second person does not have the mask extending down below their chin. The third person has gaps on the side. What you can see here, when you don't wear your mask below your chin, you have gaps on the side. That's why you must stretch your mask out completely. That's why the straps are located where they're located. The expectation is that you stretch your mask completely and you pinch the top of your nose so that it can create, it will eliminate any access that the airborne virus has to your human cells. So those first 3 people may as well not wear masks. And then the fourth person is someone who didn't pinch the top of her nose. So therefore, there's gaps on the side of the nose like this reporter has, and there it can have access to your nose and your mouth that way as well. And then obviously the fifth person is wearing the mask like a turtleneck. So she needs to just might as well take her mask off as well. So the point of the masking is that the last person, that is one, it should be a medical grade mask. If it's not a medical grade mask, it should be a multi-layered mask, at least 2 layers or greater. Otherwise, it's not going to prevent the virus from having access to your nose and your mouth. And then the last thing I'll say is the big 4. So studies have shown that zinc, vitamin D, vitamin C, which I take in the daytime, in the morning, and then melatonin, which I take at night, those big 4 things, which you should talk to your doctor about taking, and talk to your doctor about the recommended daily amount. We won't prescribe the medications for you, but you should just know from a knowledge perspective that zinc, vitamin C, vitamin D, and melatonin have been shown to either prevent the virus from, and not like a vaccine. So you should still get the vaccine, but until then, it will make it difficult for the virus to attach to your cells, punch holes and deposits RNA, or it will mitigate the inflammatory reaction that leads to the symptoms that many people have once they're infected. And then if you want to test your mask, this is called the flow test. Hold a candle or a match 6 inches in front of your face. Clearly, this reporter is not following the 6-inch rule. That's about 3 or 4 inches. And then you blow through the mask, assuming you're wearing the mask properly. And to the extent where you can blow out the candle or move the flame significantly, then that's the wrong mask. So you should consider that. And then there's the COVID-19 long-termers. People who have been exposed to COVID-19, because I'm often asked, what are the long-term effects of COVID-19? To convince you to get the vaccine, you can have kidney, lung, and central nervous system, brain or spinal cord, long-term effects. So you do not want to experience those. We're opening clinics now to treat people who have long-term effects of COVID-19. They call them long-termers. If you saw 60 Minutes about 4 or 5 Sundays ago, they talked about long-termers. I invite you to go and Google that and watch that 60-minute series. But this is real, ladies and gentlemen. These are people who have been exposed. Thank goodness they're alive. But the vaccine will not only prevent you from having long-term effects, but it'll prevent you from being hospitalized and needing a ventilator and certainly dying. With that, I will stop Brother Basilis, and yield the microphone to you, assuming there's time remaining for us to do questions. Thank you.
Absolutely, and thank you again, Brother Eadie. I've sat through this presentation 3 times now, and I've learned something every single time. So thank you. And we will take a few questions. You've answered a decent amount, but we will take a few. One of the questions here is, if you are currently infected with the virus, would the vaccine still work? And if so, how will it work?
So if you're currently infected with the virus, here's what I'll say to you. If you are currently infected with the virus, one thing you may want to do is ask for, once you're done with the symptoms and you've reached the 10th day and you've been fever and symptomatic, asymptomatic, or symptom-free for 3 days, and your doctor can help you with that, then you may want to get an antibody test to assume that you have antibodies. Remember, the purpose of the vaccine is so you can create antibodies in enough people so we have herd immunity. So that's the next step you should do. In the event you don't have access to that, the bottom line is you still need to take the vaccine, whether you've had COVID or not. You've only had it since February at the earliest. And what we do know is that even though you may have had COVID-19, your antibodies won't last forever. And therefore, you can get it again. You've heard about people getting the virus more than once. So you should have in your mind, whether you've had COVID or not, currently or in the past, that you should be in line for the vaccine as quickly as possible. Thank you.
Thank you. Next question. If we get the vaccine, is it important to obtain both doses from the same brand? For example, first vaccine from Moderna should also be from Moderna.
Absolutely. Great question. Great point. So I should have mentioned that. You cannot get the first vaccine like I did, a Pfizer, and then go back 30 days later because you went back a week late and ask for the Moderna or AstraZeneca or Johnson. You have to stick based with the science. And the science says if you got Pfizer, they only know what's going to happen if you get the Pfizer the first and second time, not if you mix the two. So don't even experiment it with yourself. If you do that, that's no different than the Tuskegee syphilis study. You're doing something that has not already been proven, tried, and proven to be true.
Thank you. Another question about the new strain found in the UK. What does it mean to be more transmissible? And is this a reference to the virus being passed in other ways than airborne illness?
Yeah, so that's very interesting. So it is not known if it's more transmissible yet. That's the controversy. And a lot of that is these factoids that are being spread around social media. They're still trying to decide. And even if it's more infectious, it doesn't mean that the outcomes are going to be more poor. And again, the vaccine has been proven to be effective at this point against any mutation. So I think the point is that even if it's more infectious, we've got to continue to do the basic things, right? Hands, face, space, and ventilation, right? So clean, make sure you demonstrate proper hand hygiene. You've got to cover your face, particularly your nose and your mouth. You got to social distance, and then you got to consider the ventilation, right? So kids going to school, people on airplanes, not out in enclosed environments, not out in the natural air. Those are the 4 things that you are responsible for to ensure that not only you not get the virus, but if you do get it, you don't spread it.
Okay. Another question. Will private doctors be able to administer the vaccine directly?
They will eventually. So remember, the Pfizer had super low, ultra low temperatures, and most hospitals and especially doctors' offices don't have access to that certain freezer. Now, here came Moderna. Well, all you need is a regular household freezer to store them, which most doctors' offices do. When AstraZeneca and Johnson & Johnson come, we believe that they're just going to need to be refrigerated like most of the vaccines that we take every single day. And that's when we will see it being pushed out to doctors' offices.
Thank you. Quick question here. How can the lack of experience and widespread data on the incidence of truly harmful side effects of this specific vaccine be addressed?
The side effects. So can you repeat that question for me, please?
So how can the lack of experience and widespread data on the incidence of truly harmful side effects of this specific vaccine be addressed?
Yeah, so here's how I addressed it personally, right? So again, I take a blood pressure medication every day. I can never give you a 40-minute presentation on it. I just don't know that much about it. I've not been interested. I just trusted the science and my primary care provider, which is very important. If you have a primary care provider who doesn't know you or your culture, I'm not sure how you can trust him or her. But anyway, two, I've been exposed to measles, mumps, and rubella and the flu vaccine. I take the flu vaccine every year, and I think I'm doing okay since I've been taking those. And then three, all medications have side effects. Anything you put in your body has a side effect. And you see commercials every single day that says, if you took this 20, 30 years ago, call my law office because we think that it could have had a negative impact on you. I submit to you that the food that you ate yesterday, depending upon what you ate, had a negative impact on you. So I'm less concerned about the long-term side effects. I'm more concerned about the short-term side effects, which is 3,000 to 4,000 people die every single day from this virus. I'm not trying to die. I don't want to see my friends and family members die. So I'm going to take the vaccine. And if I live 30, 40 additional years, I worry about those side effects when that comes about. But nonetheless, the science suggests that right now, there's no reason to think that we're going to have any.
So last question, can you speak to the allergic reactions that have been reported from the vaccine?
Yes, sir. So I'm a person who has carrying an EpiPen, but I don't, but I make sure that I have access to it. When I took the vaccine, since I was one of those high-risk people that you heard about, I think in Arizona and in the UK, the percentage of the people, remember, we vaccinated over almost 1.5 million people in this country. You've only heard about a couple. You can count them on my hand probably of the people that had an anaphylactic reaction. People have that same percentage of anaphylactic reactions. I'm an ER doctor. I took care of those every single day. So we didn't see an increase in the incidence or the prevalence of anaphylactic reaction. So there's no reason to think that the vaccine causes anaphylactic reaction. Yours truly, who's very prone to anaphylactic reactions, anybody who knows me knows that you can hear me occasionally wheezing. I have multiple seasonal allergies. I have asthma. I've got eczema. I've got the whole shebang. I'm the guy who gets vaccinated with a new vaccine and has anaphylactic reaction. And although they had EpiPen available when I took my vaccine, I didn't need it. I did just fine. So there's no reason to think that if you take the vaccine, you'll be predisposed to an anaphylactic reaction.
Thank you. That was the last question. What we'd like to do is put the poll question back up for everyone to answer. We want to take this poll, the second poll, to gauge kind of what we're doing in terms of presenting the information. These polls, begin first and second, are very helpful in terms of us tailoring our presentation to make sure we're providing the information in an easy to understand manner. Again, I want to thank everyone for attending this. Hopefully, you've learned something tonight. Again, to my esteemed brothers, Dr. Eadie, Greg Jones, thank you again. Dr. Eadie, especially, you've been doing these presentations for tons of organizations privately, on the news and everything. So thank you again, brother. It's been greatly appreciated. Brother Jones, thank you again for your leadership and guidance in terms of dealing with our communities and communicating and gathering data around this. Any final closing thoughts, gentlemen?
I would, I'd say once again, Dr. Eadie, just powerful stuff. This is the kind of roadshow that we like to do. My last comments are, you don't get a more trusted, more informed advisor than Dr. Eadie. But I would say, as we've said all along with the things we do at Omega with our Black Men's Health series, be informed, which is what we tried to do tonight, and be responsible.
Yeah, thank you, Brother Jones. And thank you, Brother Basilis and Abby, for providing the support that we needed to have a successful conversation today. I'll say this. So we're in the midst of the holiday season. We saw after Halloween and Thanksgiving, we saw an increased number of hospitalizations. We saw an increased number of infections, which led to an increased number of hospitalizations, which begat an increased number of deaths. We're not done yet, ladies and gentlemen, because there's Christmas, right? And what we just did for Hanukkah, we gather with our families. Christmas, we're still gathering with our families. New Year's Eve, New Year's Day, more gatherings, and then Three Kings Day. So this is the beginning of the worst part of this pandemic. The least we can do is demonstrate proper hygiene, is cover our faces, social distance, and consider our ventilations. But the only way we can overcome this vaccine instead of waiting for an average of 6 years for one to become available, because many people out there are saying don't take the vaccine because they sped it up. We don't have 6 years to wait. Many people that participated in this call today will not be alive if we waited 6 years. God gave us, I believe, the knowledge, the science, the vaccine. Shame on us as a people, the ones that are dying at a much higher rate than any other group of people on the planet, if we don't at least give ear to the knowledge that people like our Basilis and this great fraternity are sharing, and then make a decision, then shame on us. And if you persuade people to not take the vaccine, please understand what you're doing. And every person that you convince who should not get the vaccine, who dies, then we need to come together and understand that that may have been the worst mistake we could have ever made as leaders in the community. So again, thank you all for participating. Thank you, Brother Basilis. Brother Jones, as usual, you're the man. You've always been the big brother to all of us. And I just want to wish, the participants peace and love through the remainder of the holiday season. God bless.
Thank you, brothers. And again, we'll close out. Again, as we mentioned earlier, these videos will be available on our website, tauiotacues.org. So definitely go there. You'll find more information about this and many other programs that we will be running. Again, thank you, everyone. God bless and have a safe New Year.